Hello YouTube, De-bodgery here. Welcome to EV Components Review. On the bench is the middle power stage for my Moto Rush controller. I'm going to show you essentially four things. First one is connectors. The second one is solder joints. The third one is going to be, continuous current paths. And the fourth one is evidences here for repair. So let's go through them. All right, so the two connectors that I showed you from photographs before were this one and this one, both on the battery minus bus. And xylene and Q-tips did a pretty darn good job. So this one here had a lot of black stuff on it, and there was discoloration on the copper that made it kind of more golden color rather than reddish. And that has all cleaned up quite nicely. So yeah, that one you don't see any of that golden, oxidation on it anymore. The xylene did a pretty darn good job of cleaning that up, which is what my expectation was. So yeah, there's still a little bit of darkening in there, but not much. This connector here, you can see it just off to the side in one of those pictures, and you can still see a little bit of the blackening in there. I have not done anything to that one. It was okay enough that I didn't care. All right, this connector right here, this is the one that showed all of the really scorching and burning and things that I thought was arcing. As it turns out, and I'm happy to say that this is the case, that was crud on the surface. And again, the xylene cleaned it off. So whatever sort of residue was on the surface of those fingers, and you're looking at the exact same angle as I took the photograph on, it's just that this one I've got my halo light on my lens, and so you're getting much better lighting in there, but that's the same connector. And with the xylene and some scrubbing with the Q-tip, I got a bunch of grunge off of there that was burnt on. So I'm happy to see that the copper fingers underneath survived, and that it was just crud that burnt on the surface. So yeah, that's an acceptably good connector. I am happy to see that the copper cleaned up and that it survived just fine. But it definitely suffered something quite hot and catastrophic, which is why it would look so burnt to begin with. All right, so the other one is this over here, and you can still see white residue behind the fingers. What I discovered once I started cleaning that one out was that that was thermal paste down there. In fact, if you look in the bottom of the hole, yeah, you can still see thermal paste underneath there. So basically, it oozed out from between the MCPCB and the aluminum heat spreader underneath it, and partially polluted that hole. And then when they pushed the two together, they never bothered to clean out the extra thermal paste, which then polluted the connection. So anyway, I tried alcohol first. That didn't really clean it up. I tried again with xylene. That kind of cut the oils in the thermal paste a little bit better, but it still didn't clean it up very well, which is why you still see residue in there. Brake cleaner would have done it, but I try not to use brake cleaner on electronics. I try to stick with electronic safe solvents, i.e. xylene and alcohol. But yeah, that's acceptably good. That's going to be fine. It's not all polluted with thermal paste like it was. So yeah, that's attention to detail. They should have never let that get like that to begin with, and they did. All right, so the next thing is solder joints. So let's look at a few here. This one here is one of my favorites. Yeah. So anyway, here is the brass connector. Here's the copper. And you have this nice gentle slope right here. My tweezers, the pointy end of it, just wants to slide right up. Makes this transition very nicely. So this joint between here and here is completely full of solder with a little bit of extra on it. It makes that nice gentle slope right there, the little curve. That is a pretty darn perfect joint. That one is really nice. I like to see that one. That's super good. All right, if we look at this one right here, and let me get the camera to focus on it. There we go. Yeah, so you notice that you've got a little line under the front of it, and you've got a 90-degree here. So it's a little bit starved here. There's no extra solder here at all. It's basically this piece joined to this one with just solder underneath them. There's not that extra little bit. You get no little curve here. This is okay. It's just not awesome. It's not like this one, which is perfect. This is a little bit starved. I would definitely like to see more solder on there. This one here is about the same. Let me get the camera to focus on it again. There we go. And actually it's a little bit worse. So you can see a little bit of a crack right underneath this part here. So that one is definitely starved more. And you have a little bit of transition over here, but not very much of one. Yeah, this is still starved. I definitely would like to see more solder on here, so you get that nice gentle curve like you see here or here. This is nice and ideal. That's a good solder joint between two parts. You get the same thing here. You know, you just got a 90 degree. It's enough for this one because there's like no little void underneath it or a low spot or anything like that. But a perfect solder joint is one where you have that gentle slope from here up to here and not a 90 degree. Definitely would have put something between those because that's a current path gap. This connection right here, again, it needs a little bit more. It's totally filled between here and here, but there's no gentle slope. It's just a 90 degree. And so that's a little bit starved. There's no extra solder here at all. And I definitely like to see that little bit of extra solder there to bring the two together. This one right there, this is seriously starved. Yeah, so the solder comes up to the surface here and over here, but you can see that it is quite empty in the middle. This is a weak solder joint. I wouldn't even call this okay. Yeah, this one definitely needs more solder added to it. That's a not very good joint. All right, yeah, you can definitely see that void down in there. There is some solder down in there, but it's way down in there. This is all completely empty all through here. That's literally an air gap between the two parts. Let's see if I can't stick one of the points down in there. Yeah, they're a little bit too thick. Yeah, there we go. Yeah, I'm down in between the two. Yeah, see that? It's just completely empty down in there. So that is a bad solder joint. It's only adhered here and over there, and none of this is in the middle. That's a pretty sucky solder joint. All right, let's see here. I think that's the other things I want to show there. I will talk about this gap, though. So, nice piece of copper. It is trivially easy to put a curve like this over here and have this piece of copper connect all the way over to this right here and not leave a gap. And, well, that's the KO Moto way. We just literally don't care. So why should we bother? All we want to do is delude you into thinking that we improved it when, in fact, we didn't. And the same thing is true down here. You know, this gap is even longer. Why did you even bother putting the copper down? Why did you even bother putting the curve on this end and do nothing down here? You literally did half the job and didn't finish. So, yeah, this is completely not acceptable. This is stupid. It's so easy to fix this, and they don't bother because they literally don't care. All right, so let's look at a couple other solder joints and see how they are. So now we're looking at the board other side around. Let's see about this one. Yeah, that angle's pretty good. We get the camera to focus. And then there we go. Pretty good. All right, so you can see a bit of a void right there. Well, that's not really that great. Again, you can see a bit of a void right there. That's also not that great. This one is adhered down, and this end of this comb is adhered down. So those are pretty good. That one is a little bit weak, and that one's even weaker yet. This back piece of copper looks okay. I don't really see any gap underneath it. Yeah, there's a little bit of a void right underneath there. That's not super good. There, you've got a little bit of a transition here. That's going to be a pretty solid solder joint. In fact, this end's going to be stronger than the other side, most likely. So, yeah, this piece of copper is adhered to this one with solder pretty reasonably well. In fact, yeah, my tweezers point on. It wants to flow right up that little bit of slope. So this has got an adequate amount of solder on it to make that a strong joint. But the comb underneath is definitely got some gaps in a couple places. This one right here. Come on, camera. There we go. So, yeah, this comb, oh, yeah, that's pretty good. So, all four of those little fingers, or whatever you want to call them, those are all adhered down. That looks pretty good. I don't see any gaps back here. That little comb is probably pretty well adhered. And this is really nice. So yes, that's got a nice transition. This one's got the little bit of extra solder, nice little curve to it. That's another one of those pretty much perfect solder joints. I like that one quite a lot. All right, so let's look at evidence for repairs, because they are here. And let's flip this back around again. And let's start from left to right. So people that do reflow soldering, that do electronics repair on surface mount stuff, they can look at this and see this. Probably most people wouldn't notice the subtle signs, but they are here nevertheless. All right, so if you'll notice, come on camera, you're not quite coming in sharp enough. See if I can't get it to get in there. There we go. All right, so here's the MOSFET. You notice this little subtle line right above it, right there. And the solder here is a little bit shinier than over here. This is from oxidization. So this MOSFET was replaced by hand, and it wasn't machine placed, and it's just a skosh crooked too. Machine placement makes everything all very nice and straight, and that's also done with solder paste that's got flux in it, and so you don't get this little line. What happens is the bad MOSFET is pulled up, another one is dropped in place while the solder is molten, and then you carefully tap it with like a pair of tweezers to get it right in place. And when you do that, you pull away the oxide layer a little bit, and you leave shiny new solder behind, and you leave that little line right there. So this MOSFET was a little bit high when it got put on here by hand, and then their reflow guy pushed it down to get it in place. And you got it just a skosh crooked. All right, this one here, this one may not have been replaced. I don't see any evidence of that line. That might be a little bit of it right there. It's kind of hard to say about that one. This one here, you definitely have some remains of that line right there and across there. This one here is also crooked a little bit. So yeah, that one was hand placed and replaced. In other words, the other one that was there was blown up. And so it was placed like right up here, and then they carefully shifted it down to get it to here. This one, you can see that little distinction of line right in there as well. So that one was very likely replaced and then moved down. This one here was stuck on here, when they first placed it on the molten solder, was quite high, because here's the line way up here, and then they moved it down, and again, you can see it's just a skosh crooked. This right here is just a little bit higher than that is right there. That one was hand placed. This one may not have been replaced, either that or they did a super good job. There's no oxide line here, so that one probably wasn't replaced. This one definitely was. Notice it's really high. The machine placing is more like this, and this one is seriously high. That one was definitely replaced. This one here, you can see that little subtle line right there. So that one was probably replaced as well, and it's also just a skosh crooked. You can see this right over here. It's kind of sloping downhill, so this one is kind of canted a little bit. Let's see, this MOSFET, yeah, you can see the line right above it where it was shifted down. Good chance that one was replaced. Yeah, this one is really distinctive. You can really see the shiny solder right here. You can really see that oxide line on it. That one was flat out absolutely replaced. This one too, you can see that decent little line. This one wasn't moved a lot, just a little bit. That one was replaced. Let's see, this one right here, you've got a little bit of a line over here. I would say maybe. Can't be sure about that one. This one definitely, you can definitely see the distinctive line. That one was for sure replaced. This one here is way high again and didn't get shifted down. Definitely got replaced. Yeah, bunch of MOSFETs got replaced. On those, yeah, this one right here, very distinctive line in it. It's pretty clear. That one got pulled and replaced, really distinctive line. That one got pulled and replaced. This one, the solder is really crufty here, so it got really oxidized. That one might just be oxidized from sitting there. Maybe that one got replaced, maybe it didn't. I can't really say, but the solder right there is pretty crusty looking. Needed some flux on it to clean that up. That one probably got replaced, but I'm not going to be emphatic about it. These ones here with that very distinctive line like that, that one was replaced. That one was replaced for sure. Yeah, those ones for sure. This one probably was. You have a much more very thinner line, because this one here was almost put into place exactly where it needed to be and just barely had to shift to get this one down to exactly where they wanted it. So their reflow guy, he did a pretty good job in getting the MOSFETs all lined up. Some of them he had to tap down, like these ones, and that's why you get that little line, or that one right there, or that one. But nevertheless, this board saw a bunch of MOSFETs replaced. I'd say 50% of them easily. So with the TOLL package specifically, this little piece on the back of it, that's like a 1 millimeter thick section of copper. It acts like kind of like a shield. If the MOSFET blows up, you don't like burn the circuit board behind it. In other words, it kind of like acts like a shield, so all the burning goes upwards to whatever is above it, and we see evidence of that on the bottom side of the logic board. So yes, definitely this board has got some evidence of repairs, lots of MOSFETs replacement. Otherwise, you don't get that little line because that's hand placing that does that. Once you put the solder paste down and you've done machine placement of parts, you don't get those lines. All right, so let's look at the underside of the logic board so you get an idea of what we're talking about here. So here's the underside of that. And all those MOSFETs you were just looking at, they are sitting in this area right here of the board. So they kind of come down to about like right there. So they're all in this area right in through there. All right, so let me tilt this board so you can see that dark spot. There we go. Oh, my alarm's going off. All right, so you can see that dark area. That's burning right there. So a MOSFET exploded upwards and burned the underside of the logic board. You can see a little bit darkening right there. That's probably another one that blew up, and there's probably one that did the same thing. You can definitely see that dark spot right there. Same thing. You know, a MOSFET was right there. It basically blew up upwards and left this burn mark on the underside of the board. And we've got one more down here, and that one is really pronounced. Yeah, this one here probably, it just sat there and went bzzz for a good little while, created a lot of heat and left a nice dark spot on the board right there. So yeah, the evidence of the MOSFETs burning up is these dark spots, because that's how a TOLL MOSFET would blow up. It would basically throw all of its heat upward and create burn marks on the bottom side of the logic board, like you see here and here and here and here. So yes, absolutely, this logic board suffered catastrophic failure. The MOSFETs on the power stage underneath it definitely saw catastrophic failure, and the evidences for this having been a repaired power stage are right here, as you can see it, because of those little lines of somebody hand placing the MOSFETs and other ones being left too high, not being placed right, or being crooked, things like that. This board has definitely seen hand placement of components, aka repair, that you wouldn't have happen with components that are machine placed. Instead, they're very nice and straight, like you see all these resistors and capacitors are very nice and straight. None of those parts died. It would have just been the MOSFETs that blew up, not the little resistors. And you see that because they are all nice and straight, and it's the MOSFETs, in fact, that do blow up, and that's why you see them a little bit high or slightly crooked or things like that. See all those lines? Because this is a repaired board. Anyway, good and bad in here, some good solder joints, some bad solder joints, clear evidences of repair on this power stage, obvious repair signs on the logic board that are really, really abundantly obvious. These ones are more subtle, and you have to know what to look for, but nevertheless, they're here. Anyway, I hope that helps some folks out. This is flat out a repaired power stage, no questions about it in my mind. Yeah, the evidences are here. They might be subtle to you, but I've seen them before. I know what to look for. This stuff has been replaced. Those little tiny lines right there above those MOSFETs, that is clear evidence that this MOSFET was shifted down by hand to get it in place, and that sort of thing does not happen with machine placement of parts. They're already where they're going to be. The solder paste has got flux in it. You just don't get those little lines because everything's in place. The solder turns molten all at once, has the flux in it, it turns nice and shiny, and you don't get the lines. That's manual placement that does that. So anyway, hope that helps. I would not buy from Moto. They clearly don't make anything that I want. In fact, this controller will become someone else's very soon after this. I am not going to even bother running it. I think this is the worst thing that Moto's ever produced. And when they said they tried something new, yeah, they did, because nobody else would, because everybody else thinks that this is a really bad idea. And I completely agree. This is a steaming turd in the middle of a steaming turd.